Hey, good morning. We're on to lesson 40. Tomorrow we'll do 41 and then we're kind of done with this semester. All we have to do now is we have to do systems of equations with inequalities. And inequality means less than or greater than sign. And so that'll wrap it up for this semester. We had a meeting last night with the math department for ALA. And it sounds like our quiz is going to be like a 2-day quiz since we don't have finals week. Normally finals last for about 2 hours and they cover everything that we've learned so far. We talked about that last night, that we're not going to disrupt the whole schedule. So we'll probably do half the semester test on one day and then half the semester test on the next day. It's a little bit harder with you people at home. I'm hoping that you aren't using resources outside of the paper that's provided in a calculator and a ruler. I do understand that some people are starting to use online apps where they'll tell you the problem, how the answer was solved and everything, but that's not really helping you. And someday when you do come back to school, it'll all catch up with you. So I get the pressure of GPAs, but get the grade honestly. All right. So today, here we are. We're going to be wrapping up graphing, linear lines. So if you'll do the warm-up real quick, I have the answers on the next page. I'm hoping by now that these things come kind of really easy for you. That's in the y equals mx plus b form, so we call that the slope-intercept form. And if we get it into that form, it's really easy for us to graph. So like in number 2, that's in the y equals mx plus b form or slope-intercept form. And our slope is the number, the coefficient, we call that in front of the x, which would be a negative 1/3. And my y-intercept is that b over there, which is negative 5. Next one, we have to do some work to get it there. But my slope is negative 1 and my y-intercept is 3. This came up last night. She said, the lady that makes the test for ALA said that there are a number of inequalities on there, and solving inequalities and compound inequalities, which we did. And they were on the last 3 quizzes, not the very last one Friday, but the previous ones, and a lot of us were missing those. And so she said there are a number of those on the test, and same thing with absolute values, which we haven't done for a while. So on Monday, we'll kind of review, and Tuesday we'll go over the answers, and then Wednesday, Thursday of next week will be the final. Anyhow, this is kind of how we graph. My rule was whatever number it is that your circle's on, you need 2 numbers on both sides. And we're really focusing on open circle means not equal to, and a closed circle like in number 5 means it includes negative 2, would make that a true statement. Today we're going to do very similar things, except for we're going to have 2 variables. We're going to have an x and a y in our equation today, so it's going to be a linear line. Okay? So that's our job today, is to graph and solve linear equalities with 2 variables, an x and a y, in the same problem. Okay? All that means is it's going to be a line. So a linear inequality is similar to a linear equation, but the equal sign is replaced with the inequality symbol. A solution of a linear inequality is any ordered pair that makes the inequality true. So this is how we kind of check our work. They said we think the solution is 7-3. Again, I was kind of disappointed with some of my kids in school because they didn't know how to check their work on that last quiz. All you have to do is plug these guys in and see if it's a true statement. This is my x value and this is my y value. So the y goes where the y is. So I have 3. It's less than, and that goes where the x is. 7 minus 1. We keep this 3 over here. 7 minus 1 is 6. Is 3 less than 6? Yes, it is. It's a true statement. So this is a solution. Okay. Over here, same thing. Plug a 5 in for the y. Bring down our greater than. Now we don't have an equal sign. We have a less than or greater than sign. 3 times 4 plus 2. That's 12 plus 2, which is 14. Is 5 greater than 14? I'm always bringing this sign down. Today we're going to talk about that rule, though, with inequalities. If you ever multiply or divide by a negative number, we have to remember to flip the sign. 5 is not greater than 4, so this is not a solution. Okay, so got the one, or you try it's on the next page. Do yours, and let's see how you did. Okay, let's see how you did. All right, I got not a solution for 1A, and 1B, I got it is a solution. Okay, all right. Now, let's talk about this. This is a whole bunch of notes, so if you just kind of follow along here for a little bit. When we're talking about the top half here, we're talking about whether it should be a solid line or a dashed line. This is very important, and I always fall bad behavior here because I'm so used to just drawing always a solid line on my linear equations. But it's an easy fix. You just go back and erase in between, make little dashes here. But here's the deal. If we have a less than or equal to, or a greater than or equal to, it's got to be a solid line. That means it includes anything that's on that mark, okay? Called a boundary line. If we have a less than or a greater than, so in other words, there's no or equal to, then we have a dashed line, like here in this example right here, okay? Now, we're going to be doing a lot of shading. I asked you to be sure to get a highlighter, and so a highlighter is really going to help you today. Notice that when we say y is greater than in both of these, we shade in above that boundary line. And when we say y is all numbers less than, that would be everything down here. And so we shade in down below the line. Okay? So kind of two rules that we have to remember. First of all, we got to decide on whether it's going to be a solid or a dashed line. Then we draw our line, and then we got to figure out, whether it's above or below that we shade it. So the three steps we do, we solve for our inequality for y. So in other words, put it into the y equals mx plus b form. And then we decide whether the boundary line is going to be a solid or a dashed line. And then we have to decide which side gets shaded in. Okay, and I'll show you how to check your work here in a little bit. So again, we're back to, can I graph quickly? That one's already in the y equals mx plus b form. So my y-intercept is a 4, and my slope is a positive. So again, in my head, I'm thinking my line has to be going up. So I can't go up 3 over 1. So I want to go down 1, 2, 3, and to the left 1. 1, 2, 3, and to the left 1. Critical that you know how to graph quickly. About a third of my kids haven't been doing their homework, and so they didn't finish the quiz on Friday. And at the end of the period, I said, you are done. Now, oops, I already made that mistake. You see what I'm talking about? I forgot, I was busy talking and I didn't decide. So this one has to be a dashed line because I don't have the or equal to sign. So very, very important. Provided I can get my pen rolling here. There we go. So as you come down, just do a dashed line. Again, that means if the dot falls onto that line, that is not a solution, part of a solution. And now I got to decide, do I shade in above or below? And a less than means all numbers smaller than that. So this is, again, where a highlighter can shade this in very, very quickly. You go right up to that boundary line, and you shade in anything over here. Now, the fastest, best way to know if you shaded in the best side, or the correct side, best side, what kind of language is that? Grammar. Let me finish shading this in and I'll show you. So, there's mine all shaded in. Now, if I want to make sure that I shaded in the right side, I always pick 0, 0 because that's an easy one to check. If I put 0 in, which my 0 would be y, is less than 3 times 0 plus 4, well, is 0 less than 4? That's a true statement. So this dot right here is in my shaded area, so I have the correct side shaded in. Okay, I'll show you on another one here where I pick 0, 0, and it's not. And we can just use our reasoning skills to say, okay, I didn't have that side shaded in, and so it's not a true statement, so I probably shaded the correct side. Maybe this will be one. Let's see here. Let's get it into the y equals mx plus b form. Sometimes kids will use the xy intercepts, and that's a little bit dangerous if we have a negative sign in here. So I would recommend getting it into the y equals mx plus b form all the time, even though we taught you graph quickly by intercepts if it's in standard form. So we have plus 6. I want to stop talking here so I make sure I get this right. All right. My light just went on. There we go. All right. So if it's in the y equals mx plus b form, there's what I got. So now let's go over and graph it. Now, as I look at my sign, I see an or equal to sign. So I want to have a solid line here. So my y-intercept was 3. I have a negative slope. So again, in my head, I'm thinking my line needs to go down. 1, 2, 3, 1, 2 over. Use my ruler. This one's going to be a solid line again because I have the or equal to sign on there. Arrows on both ends. And now this says y is all numbers greater than. So I'm going to shade in this side, the top side above this line. Now as it becomes a steeper line, sometimes it's a little bit harder to tell what's above and what's below. And so it's always good to have a strategy for knowing if you did the right side or not. Shade it in. Now here's my strategy. Here's 0, 0. 0, 0 is not on my shaded side, so it should not work. So if I plug it into the original equation, it should not be a true statement. Is 0 greater than or equal to 6? It's not. So I don't have that side shaded in. So I do have one on the other side. Now you could pick something over here like 4, 4. You can pick anything in this side and you put it into that equation. It should be a true statement. So we have tons and tons and tons of possible answers. Okay? So that's how we do linear inequalities. Okay? All right. So here's the you try it. Give it a shot. I have the answers on the next page. So when you're done, just unpause your video and come back and let's see how you did. I had to squeeze in my 1C, so it's kind of a little weird and not in the same order as on your paper. I'm hoping that on 2A that you had a similar graph to that one. Should have been a dashed line. That's very important. And then also I had a dashed line on 2B and everything was below the line. Notice on 2A that if your slope was wrong, very, very important here. We'll see where I can highlight it. We had to at some point divide by a negative number. And so whenever we divide inequalities, multiply or divide by a negative number, we flip the sign. So you'll notice that I flipped the sign. I think we had to do that on 1B as well. Yep, I flipped the sign because I divided both sides by a negative 1 to get that y by itself. So again, very important rule that they expect us to know. All right, this one was already in the y equals mx plus b, so that made it nice. Quickly graphed it. It's a negative slope. I look at my line, it's a negative slope, and this one says y is all numbers greater than that whole amount there, so above the line should be shaded in. All right. Today's word problems are kind of a little bit weird. I gave graph paper, but it's kind of like not the best graph paper scale, but we'll just bust on through it. The one that you have to do is kind of like a tiny graph, but that's okay. All right. So on this one here, Sarah can spend at most $7.50. So that's kind of like pretty important. There's her total on vegetables for a party. She said broccoli cost $1.25 a bunch, and carrots cost 75 cents a bunch per package. So now we have to make a decision. We have to label it so we know who to call X and who to call Y's. So what do we want to kind of do down here on the X-axis? Let's put broccoli down there. So label your axes so that we know who's who. Broccoli. So that must mean this over here is carrots. Okay. Now let's go look for our totals. One of our totals was $7.50. Actually, in this problem we only have one total. And I want to have some math over here. Now, do I want to use B? Yep, B's and C's. I want to use B for broccolis. So I don't know how many bunches of broccoli I'm going to buy, but I want to buy, each one costs $1.25. So I want to use a capital B for that. And my carrots, which I want to buy some carrots, I want to add it. They're 75 cents a piece or a pack. but I don't know how many carrots I can buy. Now I have to decide, instead of an equal sign in here, I need to decide, do I want this side over here on the left to be more than $7.50 or less than $7.50? And so you have to kind of think about, if you're going to the store, we need this amount over here to be less than this. If we were to get to the checkout stand, she said it's $9, what you bought over here, you won't have enough money. So it has to be a less than, and then we have to think about, what could it be or equal to? And it could be, if she said it's $7.50 and that's what you had in your pocket, you still could get out of the store safely and everything would be okay. So 2 ways we can do this. As I look at this, I don't see any negative signs in this, and so this is in standard form. So I could just find my x and y intercepts. It's all up here in the quadrant 1. Most word problems are. And so we don't have to worry too much about, the sign flipping too terribly much. So I'm just going to take and find my B intercept, which would be my broccoli, and I'm just going to put a 0 in for the C. So that means I'd take $7.50 and divide it by 1.25. Oops, I didn't do that right. And I get 6. So my broccoli intercept is 6. And now my carrots, which would be $7.50, and I already know this answer is 10. Just divide $7.50 by, so I put a 0 in for this, and this went away. So that means divide both sides by 75 cents. So my C is 10. So this graph, this one's okay. So my x-intercept is 10. Let's draw our line. It's a solid line because I have or equal to, and now my sign says I want all this over here to be less than $7.50. So less than means this side right here. And now they said, well, give me 2 combinations, which there's many, many, many different combinations you could buy. Nobody said you had to spend the whole $7.50. So if they ever ask me, on a test or something, give me 2 examples that work and an example that doesn't work, I would stay away from that boundary line. You could pick things like this one right here. I could say, I want 2 broccolis and 3 carrots. So you could say 2 bunches of broccoli and 3 packs of carrots. They said 2 combinations, so let's pick another one. I want to put a different color pen here. I could buy 1 bunch of broccoli, and 5 packs of carrots. Because that would be right there, and that's in my shaded area. You can pick any combination of anything in here. You just got to kind of sometimes think about carrots in a package. Probably it's a whole number, and the broccoli is probably a whole number because you're buying bunches in the pack. Okay, so I don't know that you could actually buy a fraction of a bunch of broccoli. Okay, anyhow, pick whole numbers underneath there. All right, now you have an example here as well. And so we're bringing 2 types of olives to the Honor Society induction. They can spend no more than $6. So there's my total, $6. I want to have some amounts over here. You're going to buy green olives. So let's put green olives down here on the x-axis. And I want to buy black olives. So let's put this on B for black over here. Okay, so go ahead and write your inequality. Pretty sure we want that amount that we're spending to be less than or equal to $6. Okay, And then use the XY intercepts. I'm going to tell you, your graph is going to be kind of tiny down here because 2 goes into 6 3 times and 2.5 goes into 6 not very much. Okay, so let's see how you did here. So I graphed it. There's my graph here. It was like 2.4 and the other one was 3 for my green olives. So I had a very small graph. Anything in this shaded area here I could. So I said I want 2 pounds and a half a pound of black olives. I could said I want 1 pound and 1 pound and I would still be safe. Okay, solid line there. That's important because we have the or equal to sign. Okay, let's wrap this up. Sometimes they're going to give us an inequality graph and they're going to say, well, write me the equation. Well, if we think back to the y equals mx plus b form, we can write an equation for this line very quickly. What is my y-intercept? My y-intercept is right there. It's a positive 2. What is my slope? And I want to find a good point. It's a negative slope. So I'm just going to put y. I want to leave my sign gone or out of the way for a bit. Down 1, 1, 2, 3 over. So I went down 1 and I went to the right 3. Just put an x behind it. Now I looked at my boundary line. It's dashed, so I don't want the or equal to. And I see underneath is, so I need y to be less than 1/3 x plus 2. Because down below the graph is shaded in. Over here, let's go ahead and write it. I want to have a y, and then I want to have my x, but let's find my b. My b is my y-intercept. It looks like it's at -2. So I'm going to put that right there. There's my y-intercept. Let's find another good dot on there. Probably this one up here. So my slope is 1, 2, 3, 4, 5 over 1. So I'm just going to put 5x. Now, this one's kind of what I'm talking about. Sometimes it's hard to say if this is above or below. This line is kind of leaning to the right. And so kind of if I continued turning that to the right, I would kind of see that above it is shaded in. So I want a greater than, and I want the or equal to sign. This is a strange one here. I don't have a y-intercept, do I? So we got graphs like this. This is an undefined slope. So we say x, and where does it cross the x-axis? It crosses at -2. Now I have to decide, do I want the less than or greater than symbol? I know I'm going to have the or equal to sign because it's a solid line. Now, I want x as all numbers something -2. And if I look, I want all my shaded in areas is greater than -2. It's like 0, all this space over here. And so the way you read a graph like that, when you can't tell if it's above or below, you use the numbers. -1 is bigger than -2. 0 is bigger than -2. So I want the or greater than sign there. Okay? All right. We have one more to do here. Let's see how you do. Do these two, and I got the answers, and that's it for the day. All right. Let's see how you did. I got x is less than -x. You could say -x plus 0 because the y-intercept was 0. And over there, I got y is greater than or equal to -2x minus 3. All right, so tomorrow we're going to need 2 colors because what we're going to do is we're going to have 2 of these lines on a graph, and then we're all done with linear lines, okay? Systems of linear inequalities is what we're going to do tomorrow. All right, we hope you have a good day. Get your answers turned in by tomorrow. We'll see you tomorrow.